Have you ever considered the moon as more than just a celestial body? What if we told you it could be a treasure trove of resources? Traditionally, the moon has been seen as a barren wasteland, devoid of any useful resources. For centuries, it has been admired from a distance, its silvery glow inspiring awe and wonder. We've written songs about it, painted pictures, and even walked upon its dusty surface. But beyond its role as a celestial muse, could the moon hold something more for us? In the last few decades, scientists and space enthusiasts alike have started to view the moon in a new light. No longer just a barren lunar landscape, they now see it as a potential source of abundant resources. This shift in perspective might seem like the stuff of science fiction, but it's grounded in very real scientific discoveries. So, what exactly does the moon have to offer? Well, it turns out quite a bit. For starters, there's helium-3, a rare isotope on Earth, but abundant on the lunar surface. This non-radioactive element could potentially be used in nuclear fusion, providing an almost limitless supply of clean energy. Then there's water ice, discovered in permanently shadowed craters at the moon's poles. This water could be used to support life on a lunar base, or split into hydrogen and oxygen for rocket fuel. And let's not forget about the rare earth metals. The moon is rich in these elements, which are essential for producing high-tech devices like smartphones and electric cars. Mining them on the moon could alleviate some of the pressure on Earth's dwindling supplies. All these resources just waiting to be tapped into. Suddenly, our silent companion in the night sky seems less like a barren wasteland and more like a potential gold mine. This new perspective transforms the moon from a barren wasteland into a potential gold mine. The discovery of lunar resources wasn't an overnight revelation. It was a gradual process that involved numerous space missions. Our understanding of the moon's resources began to take shape with the Apollo missions in the late 60s and early 70s. 6 manned missions successfully landed on the moon, bringing back a total of 382 kilograms of lunar samples. These samples, consisting mostly of rock and dust, revealed the presence of silicon, iron, magnesium, and titanium, among other elements. However, the most significant revelation of the Apollo missions was perhaps the discovery of tiny amounts of an isotope called helium-3 in the lunar soil, or regolith. Back on Earth, scientists speculated about the potential of helium-3 for nuclear fusion, a clean and efficient source of energy. However, the extraction of this isotope in useful quantities remains a formidable challenge. Fast forward to the 21st century, and space exploration took a significant leap with the advent of robotic missions. In 2008, India's Chandrayaan-1 mission detected evidence of water molecules on the lunar surface. The discovery of water was monumental, not just for its potential as a life-sustaining resource, but also for its potential use in rocket fuel. The following decade saw further confirmation of water's presence on the moon. NASA's Lunar Reconnaissance Orbiter discovered water ice in permanently shadowed craters at the moon's poles. These craters, untouched by sunlight, are as cold as -250 degrees Celsius, allowing water ice to persist. But the discovery of lunar resources is an ongoing journey. Further space missions equipped with more advanced technology continue to unravel the moon's secrets. They provide us with a better understanding of the moon's geology and the potential resources it harbors. The moon, it appears, is not just a barren rock orbiting our planet. It is a treasure trove of potential resources. And these resources might just be the key to sustaining long-term human presence in space. These discoveries have paved the way for the possibility of lunar mining. Imagine a future where we mine the moon for resources. It's not as far-fetched as it sounds. As we venture further into the cosmos, the moon, our closest celestial neighbor, could very well become a vital pit stop for space exploration. And it's not just about the moon's strategic location, it's also about what the moon has to offer. Think about water ice, a resource that's been confirmed to exist on the moon. This isn't just ordinary ice. It's a 2-for-1 deal that could revolutionize space travel. Water is, of course, essential for life support, but when broken down into hydrogen and oxygen, it can also serve as rocket fuel. Essentially, the moon could become a refueling station for spacecraft, making long-distance space travel more feasible and cost-effective. But there's more to the moon than just water. The moon is also home to an isotopic gold mine, helium-3. This isotope is extremely rare on Earth, but abundant on the moon. And here's the kicker. Helium-3 has the potential to be used in nuclear fusion, a clean and efficient form of energy production. If we could harness this energy, we could power not just our lunar bases, but also Earth itself. So what does this all mean? Well, it's simple. Lunar mining isn't just about digging up moon rocks. It's about unlocking a new era of space exploration and energy production. It's about establishing a lunar economy that could drive technological advancement and stimulate economic growth. And while there are indeed challenges to overcome, such as the technical difficulties of mining in space and the legal and ethical implications of exploiting lunar resources, the potential rewards are enormous. The moon, with its untapped reserves of water ice and helium-3, could become a hub for space exploration and a powerhouse for energy production. The moon isn't just a silent spectator in our night sky. It could be an active participant in our future, a key player in our journey into the cosmos. The moon could hold the key to our future in space. The concept of lunar mining isn't just theoretical. There are already plans in motion. The moon, our closest celestial neighbor, has piqued the interest of space agencies and private companies worldwide. They are all gearing up with a shared vision of tapping into the moon's rich resources. The most prominent among them is NASA's Artemis program. This ambitious project aims to land the first woman and the next man on the moon by 2024. But that's not all. Artemis also plans to establish sustainable human presence on the moon by the end of this decade. And to achieve this, lunar mining plays a crucial role. The program plans to extract and utilize lunar resources, especially water ice, which can be converted into drinking water, oxygen for breathing, and hydrogen for rocket fuel. On the other side of the globe, the China National Space Administration is also making strides with its lunar exploration program. China's Chang'e missions have been designed to explore the moon's surface and conduct geological surveys with an ultimate aim of mining lunar resources. The Chang'e 5 mission, which successfully brought back samples from the moon in 2020, was a significant step towards this goal. Private companies are not far behind. For instance, Blue Origin, Jeff Bezos' space travel company, has unveiled its lunar lander, Blue Moon. This vehicle is designed to deliver payloads to the moon, aiding in the establishment of a sustainable human presence there. Similarly, SpaceX's Starship, under Elon Musk's vision, is set to carry out cargo missions to the moon, paving the way for future lunar mining operations. Indeed, the moon is no longer just a celestial body to admire from afar. It is rapidly becoming a destination, a new frontier for scientific discovery, and a potential gold mine of resources. As these plans take shape and unfold, one thing is clear: the race for lunar resources has begun. The potential of lunar resources is immense, and we're just beginning to tap into it. As we've explored in this discussion, the moon is not just a barren, lifeless rock orbiting our planet. It's a veritable treasure trove of resources that could potentially fuel our future space missions and even transform our economies here on Earth. Let's recap. We've delved into the types of lunar resources, from water ice hidden in shadowy craters to the vast quantities of helium-3, a potential clean energy source. We've also examined the potential uses of these resources. Imagine, if you will, a future where lunar water can be converted into rocket fuel, or where helium-3 powers our homes and cities. But let's not get ahead of ourselves. There are significant challenges to overcome. Mining the moon is not as simple as digging a hole in your backyard. It requires advanced technologies, some of which are still in the developmental stage. And even then, the harsh lunar environment and the immense distances involved pose formidable obstacles. Then there are the ethical considerations. The moon, after all, belongs to all of humanity. How do we ensure that its resources are used for the benefit of all and not just a privileged few? And how do we prevent the moon from becoming another battleground for geopolitical rivalries? These are complex issues, and they will require international cooperation, thoughtful regulation, and perhaps even a new understanding of our relationship with the cosmos. But if we can navigate these challenges, the rewards could be monumental. As we look to the stars, we might just find that our next great adventure begins with our closest celestial neighbor, the moon. And who knows? In the not-too-distant future, the phrase "the sky's the limit" might take on a whole new meaning.